Yeah, thank you very much, Paula. Thank you for the invitation to this event. So, as you said, we're gonna present to you the product we developed, which is named SoYield. It's a decision support tools that has the objective to help farmers estimate their fruit tree yields. It was initially developed in Senegal for mangoes, and it is now being also developed for citrus in North Africa. So with me is Emile, Dr. Emile Faye. SOWIT has been developing this product in partnership with CIRAD. The idea came from them initially, and we came afterwards in order to deploy the product and industrialize it. And that's also what we're going to discuss here. Also how and why we did use YOLO and how it helped us in the industrialization of the product. Emile, maybe you want to say a word or?
No, go ahead.
Okay. So you can go to the next slide. The idea behind SOWIT. So first, we're going to just give you a quick description of what we do at SOWIT and at CIRAD in order to give you the context behind this product. So at SOWIT, our goal is to develop products that help bridge the data gap between farmers and agro-organizations that what are food, financial, or governments that need data. And what we're trying to build here is what we call the virtuous circle of data, where farmers get information about how to manage their farms. We at SOWIT consolidate this data and bring it to these organizations that have then the ability to develop products that are more adapted to how farmers more adapted to the farmers. So we're talking here about financial inclusion, insurance, and a suite of products that help manage the risks of the farmers. So the problem and the idea that prompted the creation of SOWIT is very simple. It's the fact that in Africa, yields are very low. If we take an example for a reference crop, which is wheat, we see that the yield is around 2.5 to 3 tons per hectare in average in Africa, whereas in other parts of the world, should it be Asia, Europe, or the US, the yield is more around 6 to 7 tons per hectare. And at SOWIT, we think that at the core of this issue is the lack of information for the African farmer, and that's what we're trying to bring. And we're bringing it through a SaaS solution. It's our platform. We have a mobile and web platform where farmers and agro-organizations can connect and get their information. So we're talking here about very basic information that can be given through the platform, like weather data, weather alerts, information about water comfort at a very high level. But we're also talking about more complex data, and that's our decision support tools. Among them, we have SoYield. So, as I said, we have tools to help farmers optimize their day-to-day operations, their pain points. So we're talking here about irrigation, fertilization, harvest date estimation, yield estimation, which is the case of SoYield. All our products are at the core using AI and machine learning in order to help the farmer on a day-to-day basis with very high precision. SoYield is a product that uses both satellite data and on-site data through smartphones, and that's where the YOLO comes in order to detect the fruits on the trees. For ag organizations, we have a web platform that allows them to assess the performance of their partner farmers and their risks, should it be credit scoring, fraud the detection, or also where there are needs of traceability. So on the next slide, we have our product suite, as I was saying. So it goes from credit scoring for banks, for example, to parametric insurance for insurers, to quality yield estimation, carbon footprint for aggregators, or governments to fraud risk, for example, governments giving subsidies to farmers. So that's it about SOWIT. I leave the floor to Emile to present CIRAD.
Good afternoon, everybody. So CIRAD is a French national public institution that make research targeted on developing countries, applied research basically, and we are trying to provide knowledge and capacity building in tropical value chains. We are present in more than 100 countries worldwide, mainly in the tropics, and working in partnership with various institutes, private, but also academics and university. Basically, our 6 main research topics are those ones, and where you can find the classic One Health approach, the biodiversity, of course, and the agroecological transition. The one we are working on specifically in this project is the one about the transition, agro-transition, to develop more sustainable and inclusive food system in the developing countries. And I am specifically working in the HortSys lab, which is the horticultural system laboratory, which aims to address the global and local challenges of tropical horticulture worldwide, developing innovation and designing with the actors sustainable horticultural systems from really small scales, the field scales, up to almost the global scales. So here I'm going to present you the SoYield project that started it a few years ago, something like 2015, if I'm not wrong, where we work in Western Africa. So we're basically in countries like Senegal, Ivory Coast, Benin, Togo, these kind of countries that maybe are not very familiar for you. So I'm going to present you in few slides, a bit of fruticulture and mangoes farming system from there. Basically, you have 3 main cropping system of mango. The first one is which say a commercial one with mono-specific plants, mango, for exports that have a pretty good yield. You have also for very small areas, a few agroforestry system, which makes the mangoes, but also citrus and other fruit crops with other crops. So they are very diverse. And then you have the one we call the extensive traditional cropping system, which is the most present, almost 80% of the, if we can say, the mango productive area in West Africa are from those traditional systems, where you have a really smallholder growers with family farming. It's almost only picking the fruits when they're ready, and they are very low resources, but still they produce yields, and with small quantities for sure, but providing fruits for many people in the country, in the West Africa, but also worldwide. Here are some pictures to have an idea of what it is, a family cropping system in West Africa. So you can see the trees that are not pruned or anything, the soil which is bare and almost only sand, really sandy soil. So we have we face difficulties to make the fruit grows properly. And you can see here the picking or the transport of fruits, which is sometimes really damaging for the quality of the fruits to reach the markets. So basically, speaking of the markets, here what we face, the challenge we face is that the lack of yield estimates, of precise yield estimates, really hamper the functioning and the development of the value chains, of the mango value chains, but the fruit value chain in general in those countries. I had an interview with the director of Senegalese mango interprofession that told me once, nobody knows the actual quantities of mango fruits produced, not the growers in their fields, but not the buyers, nor the national statistic organism or institute that have no idea of the national production finally. So this is the main challenge that we are trying to address. And working with the actors of the value chains, we spotted the different needs regarding these yield estimations from the growers that for sure need to know how many fruits they have in their fields before buying, for example, selling it, for example. The buyers want to know where they can buy fruits at a precise date and in quantity that they need. So they need to be in relationship with the growers. And then you can go up like this in the value chains up to the national institution or policies that need data at a specific level and accurate data to drive agricultural policies at the national state, for example, and up to the research institutes such as CIRAD that need more and more reliable big data to address their research questions, such as which are the drivers of the production of mango in Senegal, for instance. So to give a small focus on the growers in West Africa, here we are in Senegal for those pictures. To perform yield estimation, they are using a traditional method, the current method, that is visual count performed on a limited number of trees in the orchards, and they choose their trees on which they're going to count the fruits, not randomly. So they go close to the place they live, or they choose the tree that carries the most fruits, such on that picture. And it gives a finally wrote extrapolation at the orchards level with a low accuracy. So we estimate less of 30%, more than 30% of error performed by these growers. And it is really time consuming for them. It's really difficult to perform this estimation, and it is dependent on the person that's going to perform the counts. So they need accurate yield estimation for planning agricultural practices such as harvesting, watering, or others such as pruning, but also to anticipate sales and sizing market opportunities. That is to say, they need to know how much food they have, or they're going to be able to sell within the next few months. And this data is not available for them yet. So from that, we start our research to focus our research based on the needs of the actors of the value chains, which is one of the specificities of applied research that we perform at CIRAD on field. So it is on-farm experimentation that we perform and centered on the user's needs. So we made a lot of interviews to understand on the field, to understand the needs, the actual needs of the users, of the future users. And the idea is to develop tools that finally gonna be adopted and that are not technology pushed or research pushed as a newly tools that look sexy for a buyer, for a funder, or for researchers, but is with low interest for user. Then we worked since 2016 on deep learning to detect and count fruits from RGB image, basically smartphone images. We started it with the faster RCNN that was at this time the reference for food detection, and we quickly switched to YOLO v4 and now on v5. which is an algorithm that we fine-tune from the COCO dataset with our own datasets on Mongo in various countries in West Africa, with more than, if I'm not wrong, something like 50,000 annotations. So we reach pretty good values with good F1 scores, and that provide an accurate automatic food detection, which is robust, working for different cultivars and different type of cropping systems that I presented you before, and which is of course really fast to count fruits. And we developed small, how to say, corrective models to put right after the YOLO detections to take into account the fruits that are not visible on the image, that are hidden or counted twice, because we take two pictures, one from each side of the tree, to get our estimates. And with this small correction, which is a linear model, we provide a pretty good tree production estimation in kilogram per tree. Then at the orchard level, we use orchard modelings to provide yield estimation with sampling strategies that we call sampling strategies that are going to drive the users to choose a proper number of trees to take into picture to get an accurate estimate with a percentage of error in the estimation that you're going to choose at the beginning. So you're going to say, for example, I need a 10% error in my estimate. And depending on the structuring features of it or chart, you're going to have a number of trees to sample. And basically, to get this kind of error of less than 10%, you need to go to take into picture between 6 and 25% of the trees in your orchard. So which is quite acceptable for them. And basically with that, we provide them with objective and accurate yield estimation in tons per hectare, or just in tons per variety, for instance. And finally, we developed models at the regional scale that aims to extrapolate the yield measurements performed locally in the orchards based on object-oriented remote sensing, and that provide areas of orchards and different type of orchards and paleoclimatic condition, basically. And with the sample orchards that we're going to have with the previous model, we're going to be able to map mango yield variability at larger scale, such as the regional scale or national scales that might interest different users and the growers. So as you can see here, before I finish and give the hand to my colleague, the machine learning algorithm here in SoYield is a part of, is just one piece of the entire working system that aims to provide the best results for yield estimation for the users. And that, you get the end.
Yeah, thank you, Emile, for the presentation. The goal of SoYield, once after it went through the research phase and we came on board, the idea was to quickly industrialize it and transform it into a commercial product with the dimension of impact, which is very important because SoYield in West Africa for growers below 5 hectares is a free tool to use. And we're saying that SoYield is a holistic solution because it is targeted to different types of users, and for each of these users it has specific challenges. So the first type of user, as Emile said, is the very small grower, and this grower usually will have the app for free, or someone will come to his farm to take to do the sampling through the app. The idea here, the challenge, is to be able to have something that's very easy to use on the field, meaning all the I would say the work that has been done around user-centric design, particularly in low connectivity areas. So it also needs to be done quite real time to give the solution and the yield estimation to the farmer once he finishes his yield estimate. And it needs to be it doesn't need to be complex on the field. So for example, for SoYield, we're only asking the farmers to take 2 pictures of a trees rather than take all the pictures. And that's where we need a detection algorithm that is sensitive enough, because depending on the trees, depending on the varieties, depending on the crop we're working on, we may have different structures, different issues. One of them, we have the different trees that can have different numbers of fruit on them, and we need the algorithm to be able to detect and accept our big farms. These farms need to estimate and anticipate the logistics on their farms, and the challenge here is not only the detection, but it's also being able to extrapolate the yield on the farm. So meaning that we go from a sample to the whole farm, and this is very important. And as Emile said, this is also another big part of SoYield. It's being able to go from a scale to another. And finally, the other users are more governments, institutions, or researchers that can use SoYield for different aspects. Emile talked about the research aspect and the ability to go further for the development, estimate other things, and governments may need it, as we already implemented this for some, to do some performance evaluation. So it starts from a mobile tool and it goes to web application, and each of these is used by different kind of users. So, and you may have understood it by now, developing a mobile tool, a tool that is very easy to use, was very important to us. So that's why the SoYield tool is limited to 3 screens, where you go from drawing your orchid to giving us some very light inputs about what type of crop, what variety do you have on the field, to sampling the crops. So you can just go to your field then, and you have small tutorial that pops up and explains to you the good way to take picture, and it's really just some common sense. And once you go there, it's just a matter of taking 2 sides of each tree with and the number of trees that you'll be able to take depends on the margin of error, as Emile explained. So we give the ability to the user to say, okay, I want 10% of error, 5% of margin of error, and this impacts mainly the number of trees that are taken into picture. And finally, as you can see at the last picture, the pictures are processed through our backend, and the result is then sent in, I would say, 2 to 5 minutes to the farmer, depending on does he have connectivity or not. And if he doesn't have connectivity, he just needs to go to somewhere where he has Wi-Fi, so that we can get the pictures, do the processing, and he will get all his results a few seconds later. So the idea, once you are able to sample a high enough number of plots and orchards in a specific region, is that you are able to build a dashboard for either an aggregator or an institution, so that they can compare their production in their different orchards, but also compare the production from one farm to another, or from one region to another. And this is very important if you want to consolidate all this information. As Emile said, currently in West Africa, farmers and let alone governments have a very, I would say, approximate idea about the yield of mangoes or citrus they are having. And this kind of solutions that consolidates a lot of data into one central point allows the farmer, allows the different kinds of users that need this data to use it. Yeah, we can move to the next slide, Emile. So regarding the next steps we're looking at, most importantly, is fruit sizing. So once you're able to estimate the yield, we farmers usually want to know the class distribution at orchard level. So that's what one of our next steps. We're also trying to estimate the yield further in the season. So currently we're 6 to 8 weeks before harvest, and we're trying to go up to 4 months before harvest. We're also trying to estimate the maturity of the fruit, so that we identify the best moment to harvest it. So we're gonna finish by just a quick use case in Morocco over citrus in the next slide. Next slide. Yeah. So this product is currently being used by multiple users. So it's being used in Morocco for citrus, in Tunisia for citrus, in Senegal and Ivory Coast for mangoes, and we're in the process of launching it in Ghana. And as you can see here with the pictures of the detections, we are on some citrus varieties that have a lot of fruits on the trees. So the detections work really well, thanks to the use of YOLO, but also to the big annotation set we had and we developed. And as you can see here, the error margin we have is around 3% for these farmers. So it's very important for them to have this kind of precision, because it allows them to estimate very accurately their supply chain. So thank you. This is it.